Hi, students. So we are going to introduce today weather maps, and we're going to use STEM scopes. All right, and this is a picture vocabulary tutorial, so hopefully it gives you a better idea of what you're looking at when you're doing the assignments that you're doing. How many of you ever look at weather channels and you see the meteorologists are talking and you're like, what are they talking about? Well, hopefully after this video and this lesson, you will be able to understand what they are talking about when they are going over those weather maps and what have you, okay? So to begin, let me just get rid of that. Don't need this. Okay, so weather. Interaction between air masses brings changes in weather conditions. You have what are called cold fronts, and you have what are called warm fronts. Air mass characteristics, you have temperature, air pressure, which can be high or low, as well as humidity. Okay. This is the day-to-day state of the atmosphere. So just depending on what type of air mass characteristics you have, you're going to have your good days, your bad days, those sunny days, those cloudy days, and we'll go into that. You also have an awesome warm-up that goes into detail as well. All right, so atmospheric movement. So when we talk about that atmospheric movement, we're going to be pretty much looking at these different prevailing winds, right? You have those westerlies, then you have the easterlies up there at the top, and right here in the middle, you have those trade winds, right? So large scale movement of warming and cooling air distributes thermal energy on Earth, right? The rotation of Earth causes the rising and sinking of those air masses to be diverted in predictable curved directions, described as the Coriolis effect. And in the Coriolis effect, if you remember, that is when you have what is more like perpendicular, okay, using that math word. You have something that's almost like a mirror image. So, for example, if you had I don't know, if you were standing over a mirror, you're seeing yourself from a different angle, but if you folded the two, they would fit perfectly together. Well, that's pretty much what you're seeing here. If we fold this little circle right here and these two touch, they would be going in the exact same direction, but because of the Coriolis effect, you have that, I guess, the illusion that something is curved, right? All right, so global air circulation patterns within the atmosphere held to Earth by gravity and warmed as heat radiates from Earth, influenced by convection of warm, less dense air. This is going to be rising air, okay? And it spreads out. And then you have cold, dense air or material that sinks, okay? Air pressure. So, in order to understand wind and weather and how things happen, you have to understand air pressure. Okay. Everyone has felt the force of air pressure when the wind blows. Okay. Air pressure is the greatest at sea level and lessens when increased distance from Earth's surface. So, air molecules are more densely packed at the sea level. All right, atmospheric air pressure is the force exerted on Earth's surface by the weight of the air above the surface. So, all of this that I'm saying, you'll understand it a little bit better when we actually get to the picture of the weather maps, right? You have your atmosphere right here. You have those particles. Notice how spaced out they are, right? But notice how the particles closer to Earth's surface begins to be a little bit more compact, right? Densely packed. So that's what right here, air particles are more densely packed at sea level, right? So not all in the air, there's kind of more spread out. But at sea level, they're more packed, densely packed. Okay. This tool, this is something you need to kind of understand, the barometer. These are tools that are used to, I guess you can say, um, I want to say it measures the intensity of the climate or the weather. So the mechanism behind the wall barometer, right here. Okay. It's a decreasing barometric pressure signals upcoming stormy weather. An increasing barometric pressure signals fair weather. An instrument that measures the amount of atmospheric pressure. So you have these all over the news station for the meteorologists to pretty much go to and observe and look at those different air pressures that are being imposed on it. Air masses, this is air masses take on properties of temperature and humidity of the underlying area. These characteristics are fairly uniform throughout the air mass and remain relatively stable as the air moves over the globe. Okay, an air mass forming over a hot desert would be dry and hot. If you ever been to Las Vegas, it is hot out there, but it is dry. Now, out here in Texas, we're not in a desert. So when we have those hot days in Texas, you're sweating, right? There's a lot of humidity, right? So one forming over a cold marine, remember marine is water, over a cold marine surface would be cold and humid. If you ever go to Galveston Beach, sometimes when the wind is blowing, you feel a little more cool air, right? It's cooler. So, yeah, it's a big difference there. An air mass is a body of air extending over a large area, so it's like 1,000 miles or more, that develops and retains specific characteristics of pressure, temperature, and humidity. So high pressure air mass, highs, and this is what you need to remember when you see the letter H on the weather map, okay? You have these highs are denser, cooler, and drier than the adjacent air. The air is descending toward Earth's surface. Highs bring pleasant weather conditions in the summer and very cold, clear weather in the winter, right? So I guess the way I like to remember that when I see the high pressure air coming, it's like, ooh, yay, we get to have an awesome day, right? Raise your hands up high, right? Okay, I know I'm corny. An air mass with greater atmospheric pressure than the surrounding air masses, air moves away from the high pressure, traveling in a clockwise direction. Remember the hands on the clock? That is a clockwise direction, okay? Low pressure, that's your L, low pressure air masses. These are going to be those air pressures and masses that bring on those stormy weather days, right? Those dark, gloomy clouds. You might even have cyclones and tornadoes and thunderstorms and what have you. So, because of the rising air in the center of a low surrounding air moves toward a low, the contact line where air masses with different characteristics meet becomes a warm front or a cold front. And you'll understand these symbols here. Notice the red symbol is going to be your warm front, and the blue symbol is going to be your cold front. Okay. An air mass with less atmospheric pressure than the surrounding air masses, air moves toward the low pressure, traveling in a counterclockwise direction. So when you have low pressure, it's not moving like the hand on a clock, but it's moving backwards. So if you look at a clock with hands on it, think of those hands going backwards, right? That's counterclockwise, okay? So warm front. Warm fronts are relatively slow moving and are characterized by a series of clouds getting lower and thicker as the front approaches. Okay. Precipitation occurs ahead of the frontal boundary and tends to be prolonged but gentle. Local air temperature changes from cool to warm after the front passes. So if you're looking at the news and you hear the meteorologist say, oh, we have a warm front coming, and you know you're going to have a hot day, right? Or if you hear them say, we have a cold front coming, okay, it's time to pull out those jackets, right? Okay. Forms at the surface of Earth when a warm, moist air mass overtakes a cool, dense, and drier air mass. So remember, warm air rises, cooler air falls, right? Look at this picture here. The warm air is going to rise and that cool air is going to fall, bringing on a cold front, or right here, we're talking about the warm front, okay? So then your cold front, these are going to be those fronts that are moving fast, steep frontal boundary that force that warm air to rise. So as that cold front is coming in, remember cold, dense material, cold air is going to always go down. Well, if the cold front is coming, then the warm air is going to do what? It's going to rise, right? So when you have a cold front, warm air rise quickly, resulting in rapid phase changes. Cold fronts are characterized by dramatic storms. It can be those clouds, those big, beautiful clouds, right? Thunder, lightning, and sometimes tornadoes. Okay. Weather map. Here you go. So, weather maps vary in scale and in data used to create them, including radar, satellite, and ground based measurements. Remember the barometer. Okay. Weather maps are valuable tools to inform about current weather conditions and to forecast upcoming weather changes. A weather map or chart shows the weather conditions at a specific point in time over a specific region. So, meteorologists, I've been saying meteorologists throughout this. Meteorologists, these are specialists who studies the science of Earth's atmosphere and the causes of weather conditions. Now, I'm going to go ahead and give you another video where it shows a meteorologist actually describing a weather map. You're going to watch that video and answer the questions that follow. Please make sure you watch the video. I'm going to ask specific questions that come specifically from that video. Okay? Bye bye.